we need to find the exact area of this shaded region. So that's going to involve some integration. When we note, first of all, that when you integrate a function that's below the x-axis, we're going to get a negative. So at the very end, we're going to have to put a negative sign in. But what I mean is you could get, say, -2, and the actual area would be 2. Well, we're integrating from 0 up to this point of intersection, and that is going to be when y is equal to 0. Now, this doesn't involve lots of complicated things. It's the only way that this could be 0 is when the numerator is 0, so when x is equal to a half. If you want, you can times through by the bottom, and you get 2x minus 1 equals 0 that way. So x is a half. So we have an integral from 0 to a half. Now, this is not the area. This is going to be the negative of the area, but we'll get to that. Of 2x minus 1 over 2x plus 3, x plus 1 all squared. Now, we cannot integrate this as it stands. It's not in the right form. But what is maybe, or hopefully jumping out at you is that this is a partial fraction scenario. We can separate it into 3 separate fractions, in fact. So off we go. I'm going to let, and so there are 3 different cases of partial fractions to be aware of at A level. There's like when you just get all distinct roots. We don't have that here. There's one where you get repeated roots, which is this one. And there's also one that could involve either of the previous 2, to be honest, but when the numerator, the order is greater or equal to the order of the bottom, i.e. if there was like a cube term here, then you have to do a polynomial division first. No such thing here, so I'm going to do 2x minus 1, get it straight into partial fractions. The only thing is that there's going to be 3 of them. It's going to be a over 2x plus 3 plus b over x plus 1 plus c over x plus 1 squared. We have to have these 2 terms in the general case. Right, multiply through. And I'm going to substitute some values in. So first of all, let x equal -1. So -3 is going to equal, now when I let x equal -1, both these first 2 terms cancel. And over here, I'm going to get -2 plus 3. So I'm going to get 1. It's just going to be c. So c is -3. That one's sorted. Next, I want this bracket to be 0. So I'm going to let x equal -3 over 2. So 2 times -3 over 2 is going to be -3. I'm going to get -4 on the left-hand side. And then it's just this term now that doesn't cancel. And I'm going to get a. Now it's going to be a times, so -1.5 plus 1 is -1/2. And -1/2 squared is going to be a quarter. So a is actually -16. And you've got a couple of choices at this point. You can either substitute a different value in that we haven't used yet, and the best one to go with is just 0 to make life easy, or quicker way is to compare coefficients, because this is an identity that's true for all values of x. I'm going to look at the coefficients of x squared. So on the left-hand side, there's nothing, so it's just 0. And over here, I've got an ax squared when I expand this bracket, so the coefficient is just a. And over here, I'm going to get 2x times x, 2x squared times b, so I'm going to get 2b, my coefficient of x squared. Very, very quick, there's no coefficient from the c. And remember, we know that a is -16, so b is going to equal 8. Let's just talk about the alternative, because I did mention it, and you might prefer it. So the alternative is to let x equal 0. It's not too much in it. Now I'm going to get minus 1 is equal to a, plus over here we've got 3b plus 3c. There's a bit more involved, to be fair. Minus 1 is going to be minus 16 plus 3b minus 9. That's going to become minus 25, which I'm going to add on to add 25 onto minus 1. I'm going to get 24 equals 3b. So again, b equals 8. So finally, that means that 2x minus 1 over 2x plus 3 times x plus 1 squared is going to be equivalent to, wait, let me put the minus here, minus 16 over 2x plus 3 plus 8 over x plus 1 minus, another minus 3 over x plus 1 squared. Brilliant. And it's this bit on the right that I'm now interested in, because we're going to put that back into our integral. So this, actually the two on the left, they're both in the form essentially 1 over ax plus b. That integral becomes a ln. Ln ax plus b. It's just that when you differentiate the right hand side, you times by a because of the chain rule. So here we have to divide by a. So very similar over here. We're going to get minus, forget about the 16, minus ln 2x plus 3, and I'm going to divide by 2, so I'm going to get 8 overall. Now I can bring that back in, the 16. You can check by differentiating, then you will get 1 over 2x plus 3 when you differentiate like the outside, and times by the derivative of the inside, that's times in by the 2. This next one's a bit more straightforward, it's just going to be 8. Remember the modulus, by the way, I didn't mention that, but you should always have your modulus around there. 8 ln x plus 1. And this one can be written as 3x plus 1 to the minus 2. And then when we integrate it, I'll leave the minus for the moment. I'm going to increase the power by 1, so it's going to be x plus 1 to the minus 1. And then I'm going to need to divide through by minus 1. So it's actually going to become plus 3. Just check back when you differentiate, times by minus 1 to give minus 3, lower the power to give minus 2, and the derivative of the inside is just 1 in this case. Let's keep going. I just need a little bit more space. Sorry, I'm jumping around a bit. Of course, in your actual solution, you work down the page from the beginning. I'm just trying to show the question as I'm doing it. Right, let's do this. So I'm going to get minus 8. I have stuck the minuses on the left. It's okay. Minus 8 ln 2 times the half is 1, so ln 4 here, and I can get rid of the modulus. Plus 8 ln 1 plus a half is 3 over 2. Plus 3 over a half plus 1, so that's 3 over 3 over 2. Then I'm minusing, put this in a big bracket, minus 8 ln 3 plus 8 ln 1. Can immediately get rid of that because log of 1 to using any base is always 0 plus 3 over 1. Okay, let's think about what to do here. So I can factor, oh, maybe I should, all right, I'm going to write 8, I'm just going to tidy it up. 8 ln 3 over 2 minus 8 ln 4. Now when I divide by 3 over 2, it's the same as times in by 2 over 3. So this is just going to become 2. Yeah, 3 divided by 1.5 is 2. And plus 8 ln 3 minus 3. Factorize the 8 out. And then minus 1. Now use rules of logs. So times all of these together. Sorry, there's a minus here, so not quite. So it's going to be 3 over 2 times 3 all over 4. That becomes 9 over 2, which I then divide by 4, I get 9 over 8. All right, we're on to the last step. This is our integral at the moment. So the area, as I said right at the start, like we've got a negative at the moment. This 8 ln 9 over 8 is going to be close to 1, but a little bit smaller, I think. And then we're going to be minusing 1 from it. So the area is then going to be equal to 1 minus 8 ln 9 over 8. Now, we're nearly there. We're just told that it has to be in the form P plus Q ln R, where P and Q are positive, which is not at the moment. So I'm going to need to basically bring that power up to make it a plus. It's going to become 8. Let me actually, yeah, well, let me write it down. 8 ln, and then it's going to be 9 over 8, all to the power of minus 1. And then finally, that's going to mean that it's 1 plus 8 ln 8 over 9. Okay, I'll just take the reciprocal. All right, nice question. Quite intricate, very easy to make a mistake, but hopefully you're happy with those steps. Good job.